Hi students, in this video we will be going over the quotient rule. Our essential question for today is, how is the quotient rule of exponents used to simplify expressions? So one more time, how is the quotient rule of exponents used to simplify expressions? So first we need to go over what is the quotient rule. Now the quotient rule is basically, kind of think of it as the opposite of the product rule. So it states that to divide two exponents, because quotient tells us that we are dividing, you need to keep the base and subtract the powers. And if you think about that, that makes sense, because when you have the product rule, which is multiplication, you have to add. And with division being the inverse of multiplication, it makes sense then that we would have to subtract the powers instead. So let's say you have a problem that looks like this, x to the 10th over x to the 4th. You have two bases that are the same. And so all that you need to do is you need to subtract the powers. Now, it's kind of similar to an equation that when you move an exponent and its base to the opposite of the line, so think about or on equations, it's the other side of the equal sign. In this case, it is the other side, either to the numerator or denominator. It becomes the opposite. So if x to the 4th moves up to our bigger number, it's going to now become the opposite, which is a -4. Which tells us then that we have to subtract. Now what happens here is that with x to the 4th gone, it's not that there's nothing there, that becomes a 1. And x to the 10th minus 4 is x to the 6th, and that's our final answer. And although that seems simple, I think it's important that we understand kind of the logic behind it and visualize it. Now if you wanted to do this in another way, you could do this by breaking up all of the x's within that x to the 10th and x to the 4th to look like this. Now obviously this looks like a lot more work than using the rule, but it does help us visualize how we get from here all the way down to x to the 6th, besides just using the rule. And basically what this tells us is, think about when you're reducing fractions. You can do a thing called cross-canceling. And the same thing happens here. I can cross-cancel a pair of x's here, another pair of x's, another pair of x's, and one more pair of x's can be cross-canceled because there's nothing left on the bottom. Now think about if you're cross-canceling. When you do that, you're dividing that number by the other one, correct? So x divided by x, that just is kind of making that a 1, right? So 1 and 1, 1 and 1. So it's not that we have nothing left in the bottom, but we're just left with the number 1. So we're left with 6 x's in the numerator and the number 1 in the denominator. And that just becomes x to the 6th over 1, or just x to the 6th. And so that's kind of how you can visually see why that rule works. Now what if we did it in the and switch the numerator and the denominator? So now it's x to the 4th over x to the 10th. So instead of moving the 10 up here this time, we're going to move the 4 again. That way it's down here, and it becomes the opposite. So once we move that x to the 4th and there's nothing there, we're left with the number 1. So that's like our placeholder. And when this 4 comes down to the denominator, it's now a -4. And the reason we do that is we don't want any negative exponents. If I move that 10 up here, it becomes a -10. And we're not really going to get into negative exponents until the next lesson. But by doing this, we are able to get the 4 down in the denominator, and 10 minus 4 is 6. So we get 1 over x to the 6th. And think about that, that's actually just the opposite of what we had before. Before we had x to the 6th, and now we have 1 over x to the 6th. Now let's visualize that. So instead of having 10 x's this time in the numerator, this time we only have 4, but our 10 x's are in the denominator. And again, we can cross-cancel, so this cross-cancels. So x divided by x is 1. Okay, we cross-cancel again. We can keep cross-canceling until we've got no more numbers in the numerator that can be paired up with a number in the denominator. So our number that is left in the numerator is just going to be the number 1, and we're left with 6 x's in the denominator, which becomes 1 over x to the 6th. So your whole goal is to try to combine the bases together, and so that it becomes a positive exponent. It's actually a pretty easy concept, so I don't think we should have too much trouble with it. So let's look at a few basic examples first. Okay, so our first example, we've got an x to the 5th over y to the 7th, or I'm sorry, x to the 5th, y to the 7th over x to the 3rd, y to the 2nd. Now, in this case, I see that the larger numbers are all in the numerator right now. So if you look at this, 5 is larger than 3, 7 is larger than 2. So I'm going to want to move everything from the denominator up, and when it crosses that line, it becomes the opposite, which means we have to subtract. So when we move this up, and everything is gone from the denominator, we're left with the number 1. And all that we do now is we say, okay, we've got to do 5 minus 3, which is right here, and 7 minus 2. Okay, and that simply equals x to the 2nd and y to the 5th. Because, yes, originally was it over 1? Absolutely. However, anything over 1 is just that number, or that term, or expression. So pretty easy. All right, now this time let's look for our larger number. So I see that x to the 8th has the larger number, and the y to the 5th has the larger number. So that tells me I'm going to keep my y's in the numerator and my x's in the denominator. So I'm going to move this y to the 3rd up to the top, but I'm going to move this x to the 2nd down to the bottom. And the goal is to move the smaller number to wherever the larger number is. Okay, so this becomes y to the 5th minus 3, because when that 3 came up to the top, it became a negative, or subtract 3. And the same thing happened with the x to the 2nd, except it moved to the bottom, to where the larger number was. So y to the 5th minus 3 is y to the 2nd, and then 8 minus 2 gives us x to the 6th. And that is it. All right, let's look at another one. Now this time we've got some coefficients in here too. So let's find our larger exponents. So I've got x to the 6th is the largest x, and y to the 3rd is the largest y. So that tells me that I am going to move the x's all to the numerator and the y's all to the denominator. Now remember, this y, you don't see an exponent, so that is y to the 1st. Now with these two coefficients, I need to reduce them. And so think about, what is 10 over 4 reduced? Well, if I reduce 10 over 4, it can both be divided by 2, which gives me 5 over 2. And so I can just write that down now as 5 over 2 and replace that 10 over 4. So I'm just reducing that. It's a pretty easy thing to reduce real quick. But now let's move our x's and y's. So again, remember, our larger x is in the top and our larger y is in the bottom. So I end up with x to the 6 minus 3 and y to the 3rd minus 1. And that simply becomes 5x to the 3rd over 2y to the 2nd. So again, we simplified our coefficients, we found where our largest exponents were, and we moved the smaller ones to them, and we subtracted them, since this is the quotient rule. All right, so as you can see, the basic problems, they were pretty easy. Now let's look at a couple more advanced problems that combine the product rule and the power rule and the quotient rule. Okay, so in this case, let's think about what rules we have. First, we've got the quotient rule, okay, because this is still a division, and we've got the power rule. Now, we need to do the power rule first. It's kind of like order of operations in a way. You've got all these parentheses that need to be simplified. And if you remember the power rule, that tells us that we have to multiply, and it's kind of like distributing, right? So we're distributing that 2 to everything on the inside. So this becomes x to the 8th and y to the 6th. And now this is starting to look pretty easy. So let's find our larger exponents. I've got x to the 8th is the larger one, and y to the 8th. Now this 2 down here, it's basically to the first power, which means it's already a positive number, so we're just going to leave that there the whole time. However, our x's are our x to the 4th, since that's smaller, is going to move up top to be with the bigger one. And our y to the 6th is smaller, so that's going to move to the denominator. And so then we use that quotient rule, which tells us to subtract, okay, our larger exponents from our smaller exponents. And so in the end, we just get x to the 4th over 2y to the 2nd once we subtract it, okay? All right, we've got only one more problem, so see, not too bad. Now this one has 3 rules in one. We see the product rule, since we have the multiplication sign right here. We see the power rule since we have our parentheses here, and we still have the quotient rule. Now your goal is to simplify everything in the numerator, everything in the denominator, and really the quotient rule is the last thing you do. Okay, so the product rule tells us that we add them. So this is x to the first, and this is y to the first. So when we add that, we know that the numerator is going to become, well, we keep our 3, and that becomes x to the fourth, and this becomes y to the fifth. Now, that's because that's the product, but with the power rule, we know we have to multiply. And this, again, if it does not have an exponent, it's to the first power. So when we multiply, this becomes x to the fifth and y to the 10th. Remember, product rule, add the exponents. Power rule, multiply them. Okay, so as you can see, we just found the solution to the product rule first. And then on the next one, we simplified our power rule. I know, it looks like a lot of writing all over the page. I know some of you guys, when you start going through this, can just do some of these in your head too, but I kind of wanted to break it down just a little bit more. So once we have simplified our numerator and our denominator, we get an answer that looks like this. Okay, and then we just find our larger exponents, which are both in the denominator this time, and we know we're going to subtract them from our smaller exponents. So the only thing that's actually going to stay in the numerator is the 3, because the 3 has a positive exponent. So that's going to stay, and this x to the fourth is going to move to the denominator, and so is the y to the fifth because they're smaller. So 3 stays in the numerator, and now we subtract x to the fifth minus that 4, so from the smaller number, and that y to the 10th minus 5. So the larger exponent being subtracted from the smaller exponent, which just gives us 3xy to the fifth. And that is probably the most difficult type of problem you will see. All right, so you have 4 practice problems to do on your foldable. Give those a shot, put your answers into Edpuzzle, and if you have any questions, please let me know. Thanks.